Hello, statisticians! Happy to be together with you today for the second part of the lesson Inference for Population Means. We are on my Canvas course because from here I can use many tools from Screencastify. Our lesson is Inference for Population Means. So let's see what's all about. We will discuss today about significance test. In the first part, we discuss confidence interval for population proportions. This for the second part, I chose population means significance test for two populations. Let's see. The anterior cruciate ligament is one of the ligaments that help stabilize the knee. Surgery is often recommended if the ligament is completely torn, and recovery time from the surgery can be lengthy. A medical center developed a new surgical procedure designed to reduce the average recovery time from the surgery. To test the effectiveness of the new procedure, a study was conducted in which 210 patients needing surgery to repair a torn ligament were randomly assigned to receive either the standard procedure or the new procedure. First question, based on the design of the study, would a statistically significant result allow the medical center to conclude that the new procedure causes a reduction in recovery time compared to the standard procedure for patients similar to those in the study? And of course, explain your answer. So I encourage you to stop the video and to reflect, to read the problem again, to reflect and to think, how would you answer to this question? So if you read the question carefully, you have meaningful hints that will help you to solve the problem. So based on the design of the study, so guys, concentrate to the design of the study, and based on this, you provide the answer. Supposing that you have a statistically significant result, will allow you to conclude that the new procedure causes a reduction in recovery time compared to the standard one. So please pause the video and try to answer to the first question. Thank you guys for thinking to the first question. Let's continue together and to see how we should answer to the first question. If you didn't answer, I provided you some hints here. So analyze if it is an observational study or experiment and explain. And think what you need to apply inference. Which one do you need? Then the second hint would be if you have here confounding variables. And you can explain this because only if you fulfill these conditions, you can make inference based, of course, on convincing statistical evidences that we suppose that you'll obtain after you perform the test. So please pause the video, try to answer to this question and to provide the answer to the first question of the problem. Thank you for reflecting on this problem. Let's see what is important. So, as we discussed before, we should focus on the design of the study. We have some important points, some important red flags that we should follow when we are talking about inference. So the first condition that appears everywhere is random assignment. And you have this condition is specified in the stem of the problem. Then it's clear that in the problem they tell you, but using other words, that these random assignments are for assign the patients to the procedure. But these procedures, guys, don't forget, it's another word for treatments because we have here an experiment. As long as we random assign patients to two different procedures, we have an experiment. Also, you need to explain, in order to make an inference, you need to explain the role of the random assignment. What is the role of the random assignment? Random assignment will help you to reduce the chance that eventually confounding variable will affect the results. So that's why the inference that you suppose that you made after you prove some statistical evidence. So, due to this fact or random assignment, and due to the fact that we have an experiment, and supposing that we have a statistical significant result that will provide the reduction of the average, and don't forget, when you see average, guys, sinks to the mean. It's another mathematical word for the mean. So it's normal to think at the population means. So if we have this statistical significant reduction, and we can obtain and we can infer that this could be attributed to the new procedure, compared to the standard procedure. And don't forget to explain that this will happen for patients similar to those in the study. Because generally, when you make inference, you need to be very specific that that inference is applied for patients or individuals similar to those that you use in the study. So don't forget about this wording in order to have a complete and accurate answer. So this is the answer to the first question. It was more about Unit 3, how we collect data for experiments, but because we have revision and the subjects are synthetic subjects, you need to be able to combine in the same problems many units for the traditional statistics course. Now let's go to the next question. Summary statistics on the recovery times from the surgery are shown in the table. So you have two types of procedures, standard and new. The sample size, 110 and 100, because remember 210 patients were selected. You have the mean recovery times in days measured recorded for the standard procedure and for the new procedure. And although it was calculated for you guys, the standard deviation recovery time in days for the both procedures. The question is, and this is our topic of today basically, do the data provide convincing statistical evidence, or we can say significant statistical evidence, that those patients who receive the new procedure will have less recovery time from the surgery on average than those patients who receive the standard procedure. Look again for patients similar to those in the study. As I told you, specify this. So please, guys, try to pause the video and try to follow the steps of inference and try to reflect by yourself. You know already the steps. So state, plan, conditions, do, and interpret. So try by yourself to perform these steps. They are very similar with the steps from population proportions, but of course the specific are different. So pause the video and try to solve. Thank you guys for the reflecting to the question B. Before solving, let's together revise the inference procedures for population means. I made a poster for you. It will be also attached to the lesson on the district side. So let's revise just a bit both procedures for population means. You deal with confidence interval or significance test, and you should choose between these two procedures. Depends on what you have in the problem. We'll discuss later this, but I think you already chose the correct procedure. Let's discuss now a bit the specific of these conditions. First step, state. What do you state? The parameters. Could be a mean, could be two means, the confidence level if you use a confidence interval. Depends what is required and depends of the specific of the data that are provided for in the problem. Or if you choose the significance test when you state, you should state the correct pair of hypotheses, null hypothesis, and alternative hypothesis, and also the significance level. If it is not specified in the problem, you will choose automatically alpha equals 0.05 or even the more conservative value 0.01. If it is the case, you can refer to the conservative value also. Plan. What do you plan? So if you have intervals, one sample t interval or two sample t interval, or if you choose on TI-84, you can look on blue here, you have t interval and two sample t interval are called procedures. If you choose significant test, you have one sample t-test, two sample t-test. Conditions for both procedures for population mean conditions are looking a bit similar with what you had for population proportions in the lesson before. Small differences. Let's see. You have two types of conditions. These are always independence and normality. Independence. You should have a random sample or two independent random samples or two groups in the randomized experiment. Depends how many population do you have, depends if you have an experiment or not. And the normality conditions, you have two situations. To be given in the problem that the sample distribution of the population it's a normal one, so to have normal distribution, or if this is not specified, if you have a sample size of sample sizes when you have many population greater than 30, then you can assume the normality of the sample distribution. Otherwise, there is another situation. It is possible to have small sample size and lesser than 30. Even in this case, you can assume the normality conditions if for n lesser than 30, the sample distribution doesn't provide does provide no strong skewness or no outliers. So you may have less than 30 sample population, but the sample distribution, if does not have a strong skewness or does not have outliers, then you can assume the normality. After you check the conditions, and don't forget to check the green conditions, the green bullet conditions for both samples if you have two samples. The next step is find confidence, find p-value, and then we have the STEM, the statistical framework in that we interpret our results. If you have a confidence interval, the STEM is the same as in the population proportion. If you deal and you chose significance test, then remember that after you perform the significance test and you calculate the p-value, this should be compared with the significance level. If it is a small p-value, that means a small probability to happen, H0, because this is the assumption, the null hypothesis to be true. But if the probability is small, it is logically to reject null hypothesis because the probability that null hypothesis to happen is small. So I insist on this because usually the students are confounding his when reject where they don't reject. So it's perfectly logic. The p-value is the probability, the chances that null hypothesis to happen, because this is what we are testing, the null hypothesis. If the chances are smaller than the significance level, small chances to happen, we reject null hypothesis. And that's why we will conclude there is a significant statistical evidence that alternative hypothesis is true, which means, and here you should come with the context of the problem. If you have the situation that the probability value, the p-value that you found before performing the significance test is greater than the significance level, of course, you have a high probability that null hypothesis to happen. That means that you fail to reject null hypothesis. So this is the wording. We fail to reject. Don't say we accept. We fail to reject. This is a statistical wording. So if we fail to reject null hypothesis, that means there is not statistical significant evidence that alternative hypothesis is true, which means, and here you interpret also in the context of the problem. So these are the steps that you should have in mind when you try to solve this problem. So I encourage you to pause the video and to try to perform by yourself these steps. Choose the approach, confidence interval or significance test. So make a decision. Try to perform each step, and after you do that, come back and let's do it together. Thank you guys for trying to solve by yourself the problem. Let's perform it together at this time. So we are to the question B. I already used the yellow color to emphasize the data for the standard procedure. The cyan color to emphasize the data for the new procedure, I mean sample size, the mean, and the standard deviation. I suppose you took the right decision for significance test. Why we choose significance test? First, because they ask about convincing statistical evidence. Usually when you have confidence interval, they ask you directly, find the confidence interval. But convincing statistical evidence could be considered for confidence interval and significance test. So that's why the main reason that we are choosing significance test is because here we deal with some wording data, wording information, wording test that we are doing. I mean, what we check? We check if the new procedure will have less recovery time than the standard procedure. So choosing this wording, we are choosing for significance test. And so we have two populations. So we will have significance test for two population because we have two sample size. Why I'm choosing this? Because it's easy for us to state the hypothesis, just go on the wording of the problem and state hypothesis and plan. Of course, if you want to use confidence interval, you are free to use, but our choice here will be for significance test because we want also to emphasize this approach. You can pause the video and you can try by yourself these steps. Maybe this time you can advance more. Thank you for pausing the video. Let's continue now with question B. So we chose significance test. We state null hypothesis. All the time when you state null hypothesis, consider the equality. This is null hypothesis. We consider the equality. It's a significance test for population mean. And we said this, we emphasize is the word mean, and we emphasize also the word average. Average and mean. We have data about average and mean. We do not have data about proportion and population proportion. So that's why we choose procedures for population means. In this order, in this sense, because the question is tailored for the mean, when the new procedure will have less recovery time on average than the standard procedure, so they refer to the mean because it's average. So your parameter will be the mean for the standard procedure and mean for the new procedure. Just follow the colors, guys, because I'm respecting the code color to be easy for you to watch what we have on the screen. So mean for standard procedure equal with mean with the new procedure. So we use equality when we state null hypothesis all the time. Indifferent doesn't matter how the question is formulated, null hypothesis will be about mean equality versus alternative hypothesis that we can test. And here you have the option, you can use inequality. So could be greater, could be lesser, could be different. We said that we have one-sided inequality or two-sided inequality if you choose different. But here you should be very confident. You should stick to the question. So if you read the question, patients who receive the new procedure, so follow the cyan color, will have less than those who receive standard procedure on yellow. So that's why we formulate standard greater mean of standard procedure greater than mean of the new procedure, because you see the blue it's less than the yellow. So this is what we have here, blue and yellow. Here is missing the yellow, but it's a good exercise for you to realize that the inequality is in this sense. Now, when you write this, don't forget to define this notation. So what represents mu of S, and here you take from the context of the problem, so represents the mean. Mu is the notation for the population mean. The mean recovery time in days along all patients similar to those in the study who received the standard treatment. So this is not difficult to just copy, paste, and adapt eventually the stem of the problem. And similarly, the mean of the new procedure will represent the mean recovery time along all patients similar to those in the study who received the new treatment. So the same wording. After you define the state, remember the plan. We already discussed the plan. So we'll have two samples, standard for standard treatment and for new treatment. So that's why we'll apply the two sample t-test for the difference between population means, or you can write for mu standard minus mu n or mu1 minus mu2, whatever do you prefer. So remember that this wording and this procedure are here in the previous pastor. So that's why I encourage you to focus on this pastor and maybe to save this pastor for future references. So let's go further after we plan conditions. Conditions are similar with the population proportion. You have two times, independence and normality. Independence means to check if you have random sampling or random assignment to the new treatments, if you have an experiment, this is what we said here, and let me remind you because the wording could be slightly different, but the sense, the meaning is the same. So random sample or two independent random sample or two groups in a randomized experiment. Our situation is here because remember, we already discussed that we have a randomized experiment, and that's why we have two groups that are chosen by random assignment. Randomized experiment refer to random assignment. That's why I told you the words are slightly different, but the meaning is the same. So in the stem of the problem, it is specified that we randomly assign the patients to the new two procedures. And if you remember, you can check here to see where they will specify the were randomly assigned to receive either standard or new procedure. So you have here randomly assigned. So this condition is specified from the stem of the problem, and when you write at exam this, you can quote the words from the problem if necessary. The second condition refers to 10%. So the sample size are greater than 10%. For the first population, we have 100. 100 it was for standard, and 100 it was for the new procedure. So this sample size, we can assume that are lesser than 10% of the whole population, all the patients who received the standard or respectively the new procedure. So we can assume that these conditions are fulfilled. The normality conditions, we said that uh, we can have in the past also. Remember, I will show you again because you can learn, as if you look many times, you can learn the conditions. It's very easy. Let's look and discuss again. So normality, we have two situations. First situation, to be given the normal distribution of the sample, it's not our case, or the sample size are sufficiently large enough, greater than 30. And this is our situation because we have 100 and 110 patients. Only other condition, if the sample size is more or lesser than 30, then the sample distribution that is given in the problem or that you built in the problem should not have strong skewness or no outliers. So for us, this condition is obviously fulfilled because our sample sizes are both greater than 30. Do the do step. The do steps, we'll do it on TI-84 because it's easier, and then we'll discuss the formula mechanics. So on TI-84, you go on stats, go on tests, choose the two sample t-test, enter the data. Don't forget to enter x1 represents the mean of the first sample, so is the yellow. Yellow, remember, we choose for standard. Standard deviation for the standard procedure is 34, and the sample size for standard procedure was 110. For the new procedure, we use the cyan color. We have the mean, the standard deviation, and the sample size. And remember, guys, that these are given in the table. There are given all of them: sample size, mean, standard deviation. So you just insert these in your calculator. Then you test when you choose the hypothesis. You should test first mean mu1. For us is the yellow, yes, the standard. Let's suppose that mu1 is standard. Could be different. This is a two-sided condition, or could be less than second mean or greater than second mean. So if you remember what we have here, so we have yellow, we have greater than cyan. Let's check this. If yellow is greater than cyan, yes, this was yellow, the standard, it was greater than the cyan, or you can say blue color, but I like to say cyan. Okay, so that's why you choose yellow greater than, you choose the last one. Then click on pull and calculate, enter, and you have the answer. Look, they will give you again what you chose. They will give you the t-value, the p-value that you need. You can notice already it's very small, and the degree of freedom. And then it's interpreting. So, but let me show you very fast. Let's quit here the previous problem, and let's go on start, and let me show you very fast where you find these two sample t-test. You see is here on 4. So just go on 4 and enter, and now you have the procedure here. Don't choose, you can switch between data and stats, but you need on stats because you have the inputs here. If you use list, you will choose data, right? But we will remain on stats. So enter stats, and then go and insert your values. So we can do this if you want to see what happened and to confirm what I told you before. So here is the sample size. Then we have the blue 186 is represents the mean. Then the standard deviation of the new procedure will be 29. And then we have, guys, the samples size of the for the new procedure is 100. Now you have the hypothesis. We do not have different. We have mu1 greater than mu2. So standard greater than new. Then go down here. You should click on to remains no, and then finally calculate, enter, and we'll have the calculator output. They give you the t-value, the probability or the p-value, degree of freedom, and they will repeat also your information. So you can pause the video now and try to interpret this output of the calculator and interpret for the conclusion of the significance test that we just developed. Thank you guys for doing this. So let's go back and to interpret using the framework from the poster that I provided before, and to remember that we discussed a bit about this interpretation, and I will explain you how to keep in mind logically to not confound these conclusions when you're comparing the p-value with the significant level. So for us, remember, we have the p-value. It's given here, and this is a very small value because e to the negative 12 means like 10 to the negative 12 power. So it will be lesser than any significant level, 0.05, or even the more conservative 0.01. So because we have a small p-value, the probability the null hypothesis to happen it's very, very, very small. That's why our conclusion will be we reject the null hypothesis. And these are the wording that you need to write. I'm explaining more in order to justify for you logically how to think in mind. But what you write should be on the framework. And guys, don't complicate to explain too much because you may become confused. So that's why it's recommended to remain in this framework. So because the p-value is lesser than the significant letter, we reject the H0. There is significant or convincing statistical evidence to conclude that for patients similar to the ones in the study, remember that this is mandatory to appear in order to be accurate. And now you'll come with the context of the problem. Those receiving the new procedure would have less recovery time on average than those receiving the standard procedure. So here it's possible for you to forget, hey guys, what is the conclusion? I forgot what I tested. That's why we first state when we start a significance test, we first state the hypothesis because otherwise it's very probable very probably to forget what we need to prove. But going back to state, remember that we rejected the null hypothesis. So there is convincing statistical evidence that standard to be greater than the standard mean to be greater than the mean of the new. Or if you go to the stem of the problem, just take it from here. The mean of the standard who receive the new procedure will have less recovery time than the mean of the patients who receive the standard procedure. So shortly, new lesser than standard when referring to the mean. So that's why your conclusion is the new procedure will have less recovery time than those who receiving the standard procedure. And that's why we'll use the word average or the word mean to be clear exactly that you refer to the mean recovery time. Okay, now the final step, the remark, as I told you, TI-84 is perfect, but many times they ask you to use the formula. Don't forget that this formula are provided by in your statistics worksheet for exam. Yes, so you have them in the paper, you just need to identify them. So for two sample t-tests for the difference of means, this is not provided with the name, but you have the formula. So you have the difference, and this is, remember, the standard deviation. S1, S2 are respectively the standard deviation for the two. One was for the standard, two was for the new procedure. This is what we establish when we use TI-84. So this is what we plug in here for that table, and you calculate, and you have the t-value. You can calculate also the degree of freedom. If you want to interpret this, remember this is kind of the t distribution, and the p-value is the tail value. So because you are greater, so you are calculating the area greater than 7.13, that is the t distribution, with the degree of freedom 207. That is the conclusion will be the same, is essentially very small. So that's why the interpretation that you'll give at the final, of course, will be the same. I attach you in this material, and I will provide for you an inference guide for confidence and hypothesis test, and using all the chapters that you studied in statistics. So I will attach this material, these iPad lessons also next to the video will be attached on the district site. So please encourage this because they will help you to understand, in fact, all the inference procedures that you studied in the AP statistics course. Thank you, dear statisticians, that because you were here with me in the review day, and I hope this material will help you to reflect, to understand better, watch the video many times. If it is needed, take notes, and try to solve by yourself after a while, and you'll see that this approach will help you to understand and to perform better inference approaches for the free response questions on the AP exam. So good luck, guys, and have a great day.